Additional Maths, Algebra, Part 7, the Quadratic Formula.
The quadratic formula. It would be good if we could find a single formula which enabled us to solve quadratic equations. Consider the equation 2x squared plus 5x minus 9 equals 0. Now this one doesn't factorise, but we can solve it by completing the square. So we start with 2x squared plus 5x minus 9 equals 0. Now we want to move the constant term, that's the 9, to the right-hand side, and we do that by adding 9 to both sides of the equation. This gives us 2x squared plus 5x equals 9. Now we can only complete the square if we just have x squared at the beginning, so we'll divide all the way through by 2. This gives us x squared plus 5 over 2x equals 9 over 2. Now we can complete the square. To do that, we take the number in front of the x, we halve it, we square it, and we add it to both sides. So 5 over 2 halved is 5 over 4, and we add 5 over 4 squared to both sides. Now, we can factorise the left-hand side. This becomes x plus 5 over 4 all squared. On the right-hand side, we've got 9 over 2 plus 25 over 16, which can be written as 72 over 16 plus 25 over 16. Now if we take the square root of each side, we get on the left-hand side x plus 5 over 4, and on the right-hand side we get plus or minus the square root of, now it totals up to 97 over 16. Now we want to get x on its own, so we subtract 5 over 4 from each side, and we end up with x equals minus 5 over 4 plus or minus the square root of 97 all over 4, which can be simplified as x is equal to minus 5 plus or minus the square root of 97 all over 4. Now we're going to do the same thing all over again, but this time, instead of having numbers in front of the x terms, we're going to have general letters. So it's going to be ax squared plus bx plus c equals 0. In the equation, a, b and c are any numbers. By completing the square, we can derive a formula for solving quadratics. So we start with ax squared plus bx plus c equals 0. Now we want to move the constant to the right-hand side, so we subtract c from both sides. This gives us ax squared plus bx equals minus c. Now we want to get x squared on its own, so we're going to divide all the way through by a. This gives us x squared plus b over a x equals minus c over a. Now we can complete the square. To do that, we take the number in front of the x, which is b over a, halve it, square it, and add it to both sides. Now b over a halved is b over 2a. So we add b over 2a squared to both sides. Now the left-hand side factorises. That gives us x plus b over 2a all squared. And on the right-hand side, we've got minus c over a plus b squared over 4a squared. So the right-hand side can be written as minus 4ac over 4a squared plus b squared over 4a squared. Now if we take the square root of both sides, we get x plus b over 2a equals plus or minus the square root of the right-hand side. Now that could be written as b squared minus 4ac all over 4a squared. Now we can subtract b over 2a from both sides, and that leaves us x equals minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a, or we can simplify it to x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now that is the general formula for solving quadratic equations. If we're given a general quadratic equation, ax squared plus bx plus c equals 0, we then substitute a, b and c in the formula, and we can use it to solve any quadratic equation. So remember, the formula is ax squared plus bx plus c equals 0, and then x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Let's have a look at how we can use the quadratic formula to solve some quadratic equations. The equation is ax squared plus bx plus c equals 0, in which case x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So, if we take the example, 2x squared minus 3x minus 6 equals 0, the first thing that we have is that in the formula, a is equal to 2, b is equal to minus 3, and c is equal to minus 6. Now, if we substitute those numbers in the formula, we have x equals minus 3 plus or minus the square root of minus 3 squared minus 4 times 2 times minus 6 all over 2 times 2. Well, that simplifies down to x is equal to 3 plus or minus the square root of 9 plus 48 all over 4, and that square root is the square root of 57. So we can leave the answer as x equals 3 plus or minus the square root of 57 over 4, or if we work it out on a calculator, taking the square root of 57 as being 7.54983, then x is equal to 2.63746, or x equals minus 1.13746. Let's look at a second example, the equation 3x squared plus 8x equals 3. Now the first thing to do is to put that equation in its standard form. So that's 3x squared plus 8x minus 3 equals 0. Now in the formula we substitute a is 3, b is 8, and c is minus 3. So x equals minus b, now that's minus 8, plus or minus the square root of b squared, which is 8 squared, minus 4ac, which is minus 4 times 3 times minus 3, all over 2a, which is 2 times 3. That simplifies to x equals minus 8 plus or minus the square root of 64 plus 36 all over 6, which is minus 8 plus or minus the square root of 100 over 6. Or x equals minus 8 plus or minus 10 over 6, which cancels to minus 4 plus or minus 5 over 3, and so x is equal to 1 over 3 or minus 9 over 3. That is, x equals a third or x equals minus 3. Now, pause the video at this point. Using the quadratic formula, try and work out the solution to the following quadratic equations. When you restart the video, I'll go through the solutions. In question A, we have x squared plus 6x minus 1 equals 0. So in the formula, we're going to substitute a is equal to 1, b is equal to 6, and c is equal to minus 1. This gives us x equals minus 6 plus or minus the square root of 6 squared minus 4 times 1 times minus 1 all over 2 times 1, which simplifies to minus 6 plus or minus the square root of 36 plus 4 over 2, which is minus 6 plus or minus the square root of 40 over 2. Now we could leave that as the answer, or using a calculator we can get the square root of 40 is 6.32456, which means x is equal to 0.16228, or x is equal to minus 6.16228. Rounded off to 2 decimal places, that's x equals 0.16, or x equals minus 6.16. In question B, we've got x squared minus 5x plus 3 equals 0. So in the formula we substitute a equals 1, b equals minus 5, and c equals 3. That gives us x equals minus 5 plus or minus the square root of minus 5 squared, take away 4 times 1 times 3, all over 2 times 1. Which means that x is equal to 5 plus or minus the square root of 25 minus 12 over 2, or 5 plus or minus root 13 over 2. Now we can leave that as the answer, or if we want to work it out with a calculator, square root of 13 is 3.60555, and so x is equal to 4.30278, or x equals 0.69722. Rounded off to 2 decimal places, that's x is 4.30, or x is 0.70. In part C, we have x squared plus 11x minus 4 equals 0. So substituting in the formula, we have a equals 1, b equals 11, c equals minus 4. So x is equal to minus 11 plus or minus 11 squared, take away 4 times 1 times minus 4, all over 2 times 1. Which means x is minus 11 plus or minus the square root of 121 plus 16, all over 2, or minus 11 plus or minus the square root of 137, all over 2. Now we can leave that as the answer, or if we use a calculator, we can get x is equal to minus 11 plus or minus 11.7047, all over 2, which means x is equal to 0.35235, or x is equal to minus 11.35235. Rounding that off, x is equal to 0.35, or x is equal to minus 11.35. In part D, we have 2x squared minus 4x equals 12, which we can put in standard form as 2x squared minus 4x minus 12 equals 0. So when we substitute it in the formula, we have a is equal to 2, b is equal to minus 4, and c is equal to minus 12. That gives us x equals minus 4 plus or minus the square root of minus 4 squared minus 4 times minus 12, all over 2 times 2, which simplifies to 4 plus or minus the square root of 16 plus 96, all over 4, or 4 plus or minus the square root of 112, all over 4. Now we could leave that as our answer, but if we use a calculator, we can say x is equal to 4 plus or minus 10.583 all over 4, which gives us x equals 3.64575, or x equals minus 1.64575, which means x is equal to 3.65, or x is equal to minus 1.65. In part E, we have the equation 3x squared plus 4x equals 21, which we have to put in standard form, which is 3x squared plus 4x minus 21 equals 0. So if we substitute in the formula, we have a is equal to 3, b is equal to 4, and c is equal to minus 21. That gives us x equals minus 4 plus or minus the square root of 4 squared minus 4 times 3 times minus 21, all over 2 times 3. Now that's equal to minus 4 plus or minus the square root of 16 plus 252 all over 6, which gives x is equal to minus 4 plus or minus the square root of 268 all over 6. Now we can leave that as the answer, or if we have a calculator, we can work out x equals minus 4 plus or minus the square root of 16.3707, all divided by 6. So x is equal to 2.06178, or x is equal to minus 3.39512, which gives us, rounding off, x equals 2.06, or x equals minus 3.40. In part F we have the equation x squared plus x plus 1 equals 0, and in the formula we substitute a is 1, b is 1, c is 1. Now this gives us x equals minus 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1, which is minus 1 plus or minus the square root of 1 minus 4 all over 2, which is x equals minus 1 plus or minus the square root of minus 3 over 2. Now, there is no real number that is the square root of minus 3. So that means there is no real solution for the equation. Now, if we look at question G, we have x squared minus 6x plus 10 equals 0. We can substitute those in the formula. A is equal to 1, b is equal to minus 6, and c is equal to 10. This gives us x equals minus 6 plus or minus the square root of minus 6 squared minus 4 times 1 times 10 all over 2 times 1. That's x equals 6 plus or minus the square root of 36 minus 40 all over 2, which is x is equal to 6 plus or minus the square root of minus 4 all over 2. Again, there's no real solution to the square root of minus 4, and so the equation has no real solution or roots. Now in question 8, we've got 4x squared plus 9 equals 12x. We need to put that in standard form. That's 4x squared minus 12x plus 9 equals 0, and so in the formula we substitute a is equal to 4, b is equal to minus 12, and c is equal to 9. This gives us x is equal to minus 12 plus or minus the square root of minus 12 squared minus 4 times 9 all over 2 times 4. Now that means x is equal to 12 plus or minus the square root of 144 minus 144 all over 8, which is equal to 12 plus the square root of 0 over 8, which is just 12 over 8 or 1.5. So this question has only one answer. X equals 1.5.